Good afternoon. My name is Salamait Wendamu, and this is the presentation for my final project, Transformer-Based Startup Sector Classification for Angel Investing. The main goal of this project is to build a text classification system for startup sector labeling. The idea is you would import the startup description, and your classification system would tell you the sector or that your startup belongs to as an output. So the idea is given this startup description, then your classification system will tell you that this belongs to the healthcare system. The reason I decided to do this is our current local investing group, we currently label startups manually. And as we all know, manual labeling is time consuming and can be inconsistent depending on who's doing it. So the idea is I would put in place an automated sector prediction that can help us with initial startups screening. The key question for this specific project is, do transformer models improve sector classification compared to a traditional TF-IDF baseline? The data set I used came from publicly available Y Combinator data for startup companies funded by them. The raw data had 5,880 startup records. After cleaning the NA and some problematic rows, I was left with 5,715 records. To get the startup description, I combined the one-liner and the long description. For my labels, I use the industry and the sub-industry columns. And I also looked at the tags and saved them for future use. They need significant pre-processing and label cleaning that would be needed before they could be used. Here's the source or here's the link you could use to source the data. So when you first look at the industry breakdown of your data, you will notice that the B2B sector actually has more than half of the data. The B2B sector made up more than half of the data, which the B2B label is too broad for effective startup classification for our use. And also, it could lead to our models over predicting B2B. So the idea I came up with was to split that B2B into sub-industry and the industry. So the idea is if you have B2B and then B2B industry and it is mapped to a sub-industry of sales, then the label would become B2B underscore sales. But then I kept the non-B2B sectors such as healthcare, fintech, consumer, and industrials intact. And then I removed their labels with fewer than 50 examples. The final setup ended up having 21 refined sector labels, and it appears, unfortunately, it has one-to-one mapping and not one-to-many mapping as realistic in reality. To compare our performance across the different models we'll be using, I used macro F1 and weighted F1 as evaluation matrix. As we talked about previously, the data set is imbalanced across sectors, which means accuracy alone can be misleading because the model may perform well on large classes while ignoring the smaller classes. In case of macro F1, the F1 score is computed independently for each class. This gives equal importance to all sector labels, thus making it useful for measuring performance on smaller B2B categories. And for the weighted F1 score is computed using class frequencies as weights. This gives more importance to common classes in the data sets, thus helping balance the performance between common and rare sectors. So together, macro F1 would provide us fairness across sectors, and weighted F1 would give us overall practical performance. As a baseline, I chose to use the traditional machine learning method of TF-IDF with logistic regression. In this case, I converted the startup description into word and phrase features based on word importance. I used logistic regression for sector classification. I also set the class weight as balanced, which handles the imbalance we've been talking about. So the idea here is that this baseline model would give us a simple benchmark and allow us to see if transformer models add value beyond the traditional machine learning methods. The transformer models I actually evaluated were Distilbert, which is a simpler version of BERT. And then I also introduced a custom weighted Distilbert, which handled the class imbalance we've been discussing about. I also looked at Roberta, which is a stronger version of BERT, but that is generally used for text classification projects. So the whole premise of this project is our transformers are going to give us a better results because many startup descriptions, for example, use very similar business language and especially in B2B sectors. So TF-IDF, our baseline model, mainly looks at keywords, while the more robust transformer models understand context and meaning. So theoretically, then the transformer models can better separate similar startup sectors for us and giving us better performance. So to set up your classification system, you tokenize your startup description using the Hugging Face tokenizer. Then you convert the text into transformer embeddings. Then you fine-tune sequence classification models on labels. Then you predict a sector for each startup company description. For the fine-tuning workflow, I split my data into 70, 15, 15, where that left me with 4,000 examples for training, 857 examples for validation, 858 examples for test. To fine-tune my my models, instead of using the PyTorch loops, I actually use the Hugging Face Trainer API, which makes it easier for me to focus on choosing a model instead of actually building an architecture or a training architecture. So the trainer API is quite easy to use. First of all, you have the training arguments object that actually allows you to set up your hyperparameters, such as your epoch, your weight decay, your watermark ratio, a metric for best model, and other unlearning rate as well. And then you could use this object and you could pass it to your trainer along with your model and your data set. Once you have trained your model, you can then use your test or your validation data test to calculate evaluation metrics to see how well you performed. The key parameters I actually set up were the max length. I chose 384 tokens after looking at the startup descriptions and their averages and medians. I chose 5 epoch to be 5, but we are using the best, we're loading the best model. And then we are also using a weight decay of 0.01. So why does it matter to do class handling? I think we talked a lot about it on previous slides. Some labels do have many more examples than others. And without actually introducing weighting, models may favor larger classes. I tried different types of different types of weights. But I think I decided in the end for the specific to present the smooth class weights. The way I calculated it was I calculated the inverse frequency class weights, then I applied the square root smoothing, then I kept the weights to keep training stable. From there, I actually created a custom weighted trainer, which takes the Hugging Face Trainer API, but then updates the loss function to use a weighted cross-interpolate loss. This will give smaller classes more influence during training. So once I have trained all my models, then I used my validation data to calculate the evaluation matrix to see how well each model performs. And based on this, you could clearly see that the weighted Roberta model quite outperforms all the other models. The transformer models improved way improved over the traditional TF-IDF baseline. And it seems like, unfortunately, adding class weighting helped, but only slightly. So once I've looked at the validation data set results, I chose the Roberta as my final model. And so I then calculated the performance metrics for Roberta and the TF-IDF logistic regression using the test data sets. And clearly, again, we could see that even with the test data set, that the Roberta weighted model actually quite outperforms the traditional TF-IDF logistic regression model. And when looking at the breakdown by sector, you could clearly see clear sectors like healthcare, industrials, education, and consumer, and real estate and construction quite actually do well and have strong results. However, the B2B sector seems to be weighing down our overall accuracy, macro F1, and weighted F1 scores. I then proceeded to evaluate what was causing my errors. The main errors that came up were from the B2B categories that are very similar to each other, like B2B other. B2B operations and B2B productivity were hardest to separate. These categories as appear often use like words like workflow, automation, platform, and productivity. And so is and so it seems to be very generic words. Another thing was some startups could actually reasonably fit more than one category. A company could be healthcare as well as AI or technology. The important takeaway that I got from looking at the errors is that improving the sector labels may help the model as much as improving the model itself. So for the whole idea for this project would then be like we would have a user come, enter a startup description, then a text is tokenized with Roberta tokenizer. Then the weighted Roberta tokenizer would actually the weighted Roberta model would then provide as a would then predict a sector label for us. So the strengths of this project is that we did use real life data, startup data from Y Combinator. I was sort of able to refine broad B2B labels into more useful investor sectors. And we did see that transformer-based models with class weights did improve performance. Now, the main limitation that I found was one was label ambiguity, as we talked about it. B2B categories often overlap, making them harder to separate than clear sectors like healthcare or fintech. And also, we're seeing a lot of the startup descriptions having marketing style descriptions. What that means is startup descriptions can be broad or vague, which makes precise labeling harder. And as we several times have talked about, some sectors had many more examples than others, and class weights only helped marginally. So for future work, I would say we could look at using the tags for multi-class label classification, but that would need a lot of pre-processing. We could try to tune the hyperparameters with Optuma or Raytune, but I think the biggest next project is to find a different, more robust data sets than the Y Combinator that allows us to map the startup description to to multiple sectors and also is actually as clean as possible, as cleaner than what I have found on the Y Combinator. That is the gist of my final project. Hope you enjoyed it. Thank you very much.